Okay, so in the last video, we created vectors. Remember, vectors have to have elements of all the same type, and we can create them in three major ways, really. We can use the concatenate function, such as this. We can use the sequence function or the rep function. And now we're going to learn how to make references to particular positions or elements within a vector, and how we can do that in very creative ways using the data structures in R. So here we've created a numeric vector. It just contains some elements. And notice if we run this numeric vector and then use the script x with square brackets around the number 4, it does not give us back 4, but instead the 4th position element, which is 10. Okay, similarly, we could create a sequence. So remember, this is the sequence operator, just like SEQ, and it creates a sequence by unit 1. So this would be the list 1, 2, 3. And so it's going to pick off the first, the second, and the third elements of this vector x. And indeed it does, 4, 7, 2. We could jump around. So we could pick off the second element, the 5th element, and the 6th element. So we get 7, 1, and 0. The 2nd, 5th, and 6th. One thing that's clever that I like about R is negatives within an index. This, by the way, is called indexing in R, when we use this square bracket to pick off elements of anything, whether it be a vector or later a matrix. And we can use negatives within indexing to drop elements. So here, -3, well, let's think. What would be the third element? The 2, right? And look, when we put the negative in front of the 3, it simply drops that third element. So we get everything else and not 2. So we get 4, 7, 10, 1, and 0. Notice that's the whole list, the whole vector x, subtracting the third element. We can do that to multiple indices. So we can have -C4, 5. So that it would pick off the 4th and the 5th, 10 and 1, and subtract them from the vector, or drop them from the vector. We can also use logical expressions or tests, such as x greater than 4. So which elements, going back to this vector, which elements are greater than 4? Well, 7 and 10. And notice if we put that within the square brackets, we just get those elements greater than 4. And finally, we can also use indexing, using the square brackets here, to replace elements. So I could say, I don't want the third position to be 2 any longer. I want it now to be 99. So I'm going to replace that third position with the numeric value 99. And when we print out x, we now see that. So take a look, make sure you can run all of this code, test it out. If you have any questions, do let me know. A little bit more, we're going to talk about 2 functions that are really useful when you're working with vectors in R. The which and match function. So which is going to give you indices where the condition is true. So let's try that out first. Here again is that same vector from before, and here we have just a test. We said, where is x greater than or equal to 4? So here, the first position, the second position, and the 4th position. And we see what we call a logical vector in R as a result. So true, true, and true, where the 3rd, 5th, and 6th positions all have false because they are not greater than or equal to 4. Well, that might be good enough in some cases, and I use logical tests like this to create a logical vector of trues and falses a lot of the time, and sometimes that's what you want. But at other times, you actually need to know the indice where it is true. And so notice if we just surround that logical test, x greater than or equal to 4, and run the which function on it, we get back the position where this test is true. So we get back 1, 2, and 4 right there. Well, related to which is also which max. And which max is just going to tell you the maximum index where that test is true. Okay. And finally, we could, oh, and I'm sorry, it's not the test, but where the element is maximum. So notice here we get back a 4, which is the highest element of this vector. It's in the 4th position, 10, okay? And so we get back that indice or index where we get the maximum number. We could get back what the actual maximum number is by then surrounding which max by square brackets and putting an x out in front. So that's going to say this is really going to be x with a 4 right here and give you back 10. Notice you also could just run max. That might be the easier way. All right, a little bit more and we'll be done here. I could create a new vector y, and this uses the rep function like we saw last time. Remember, we're operating on that sequence, and then we do it times 5 to 1. Well, this is a little bit more complex than we did last time. What is it doing? Take a look at the result. Here we have 5 1s repeated. That's the first element within our sequence here of 1 to 5. Then we have 4 2s. Okay. Then 3 3s, 2 4s, and 1 5. So notice it's taking the times option here within the rep function and applying it to each of the elements individually. So the first element 1 gets repeated 5 times, the second element 2 gets repeated 4 times, and so on. Then what we can do is we can match 1 to 5 to y. And what match is going to do is it's going to give you that first position of that particular element within a vector. So notice the first position of 1 in y is the first place. Then the first position of 2, the next value in the sequence of y, is in the 6th place. See, 1, 2, 3, 4, 5, 6. Then the position of 3, where's that first position? 10th place, right there. Where's the first position of a 4? 13th place. Where's the first position of a 5? Well, the 15th place. So match will give you those positions of that first element. We could also run the function unique. Go ahead and run unique real quick. What is that going to give you? It's just going to give you the values that are unique within y. So it'll give you back 1, 2, 3, 4, 5. But then if you run match on unique y, it's still going to retain the position that it was in the original y. So notice these are identical because it retains the position in the original vector y.